Okay, let's have step 1. Now, your HO and H1 is formulated in step 1. Now, your H1 is usually indicated in the problem. So, according to the problem, we are to test that the mean difference is greater than 2 pounds. So, your HO would be the complement of the symbol less than equal, then copy the rest. Yan. Now, this 2 is your hypothesized difference, no? The value of your D sub O. Now, your step 2 is given in the problem, your level of significance is 0.05. Then we go to step 3. We are to use the formula T is equal to D bar minus this is D sub O, okay, over S sub D over the square root of N. Your S sub D is the standard deviation of your D bar, or standard deviation of the difference. Okay, so that's in the step 3. Let's go to step 4. Your step 4 is the critical region. Remember that your step 4 may depend on the direction you indicated in your H1. So that's a greater. So we use here greater, and we are looking at T computed greater than the T alpha V. Okay. Since this is a one-tailed test, kasi one direction lang, we have only alpha, hindi siya alpha over 2. Now your T is greater than the T at your alpha 0.05 degrees of freedom V. But your V is n minus 1. And there are 5 paired observations. So 5 minus 1, we have 4. So this is a degrees of freedom 4. So your T computed must be greater than, if we look at the table here, T at 0.05, tapos 4 ang degrees of freedom here, 2.132. Okay, so we have T is greater than 2.132. Okay, let's go to the computation, step 5. Now in your step 5, we need D bar. D bar is summing up the differences over N, I from 1 to N. Now your N is 5, and the sum of your D sub I, okay, let us compute first your D. This is our data. How do we get the difference? We use x sub 2 minus x sub 1. This is arbitrary in the selection. You may also use x sub 1 minus x sub 2. But why do we choose x sub 2 minus x sub 1? Because there are more positive values for the difference of x sub 2 minus x sub 1. So this is 3. 45 minus 42 is 3. This is 1, this is 1, this is 1, and this is 8. Okay, so that our D bar is summation of D sub I over N. So this is actually 14 over 5. So our answer is 2.8. So this is our D bar. Now your D bar is 2.8. We need also the standard deviation of the difference. Now the standard deviation is equal to this. Okay, we have N summation of D sub I squared minus summation of D sub I quantity squared over N times N minus 1. Okay. Your N is 5. Now how do you get the summation of the square of the difference? So let's add additional row here where we have the D squared. This is 3 squared, that's 9, 1 and 1 and 1, and this is 64, so that our summation of D sub I squared is equal to 76. Okay, so that this is 76 here, minus summation of D sub I, we have it here. Okay, so we have 14, but don't forget to square that over 5 times 4. So our S sub D is actually 3.03. Okay, let's go to step 4, step 6 rather. Now your step 6 is dependent on your step 4. See? Is your computed value greater than 2.132? So, 3.03 is indeed greater than 2.132. So, we reject HO. So, ano yung HO natin? Your HO is this, and this is rejected. So, we conclude the H1. And that is our step.